So first of all, thank you all for being with us today. Thank you for the speakers to be here and for all the participants. And let me present the speakers of this amazing roundtable. So who we have around us here today? We have Anilkumar, who is the Head of Innovation and Technology Transfer at the Italian Space Agency. Hello.
Hi, everyone.
Hi. We have Luca Maresi, who is the Head of Optics Section at the European Space Agency. And
Good afternoon, everybody.
Hi, Luca. I know that you are also the organizer and chairman of the Small Satellite System and Service Symposium. And I would like to remark here that the next year, this conference will be held between the 2nd and the 3rd of March 2021. And we have also Alessandro Zuccaro Marchi. Hi, Alessandro.
Hi there.
Alessandro is organizer with Luca of the Forest Symposium. He is optical engineer at the European Space Agency. We have Davina Maria di Cara.
Hi, everybody.
Hello, electric propulsion engineer at the European Space Agency. We have Michèle Lavagna.
Hello.
Professor at the Politecnico di Milano at the Aerospace Science and Technology Department. And Francesco Barato.
Hello, everyone.
Hi, professor at the University of Padova at the Industrial Engineering Department. So before starting our discussions, I encourage all the participants to write your comments, your thoughts, your questions on the chat, as we will make our best to interact with you. So don't worry also in case your question and comment will not be discussed today, as I will make my best to have written replies from our speakers and put them in our T4I website event page. And we also are recording this event, and we will publish the video on our YouTube channel. So you will have the chance to see this panel again. So let's go into the discussion. We have a lot to say about how satellites can improve our lives and how space mobility can affect satellite efficiency. So let's start from the main problems of humanity. To list them, I like to refer to the SDG, that are the Sustainable Development Goals that were set in 2015 by the international community. And countries of the world collectively pledged to eradicate poverty, find sustainable and inclusive development solutions, ensure everyone's human rights, and make sure that no one is left behind by 2030. So the question for our speaker is how these problems can be solved by satellites. And can you provide some practical examples referring to the SDG goals? So Anil, what do you think about this?
Oh, so I'm the icebreaker.
Yes.
Of today. Okay, so definitely data is the new black, as we all know. Is also defined as the new oil for the future, because we have plenty of data. We have a lot of data nowadays coming from satellites. If you think at the Earth observation data, or at navigation data, positioning systems, and all this data put together, so mash up with maybe other kind of data, so you can find and imagine a lot of solutions to face SDGs problem. And by the way, now the new trend is not only using data, satellite data or technology, and I will come back to this later on, but using data not only to face one single SDG at a time, but basically the new black, again, the new fashion white is putting SDGs together. So the nexus concept. So more SDGs together. So clustering the SDGs and having data and information extracted from this data, space data, of course, tackling more than one SDG. Last but not least, in my opinion, technology is also another key driver. So we have a lot of examples, and this is part of also my role at the Italian Space Agency, using technologies coming from space for non-space activities, and definitely health, or using high-end technologies to develop low-end maybe a product like prostheses or maybe sensors or things like that are definitely of very much use to tackle the SDGs. So space is closer to SDGs more than we think.
Yes, normally I think that Sometimes, as we cannot see, space is not as near as Earth. It's difficult now to think also about this. And Luca, I would like to hear also your point of view as you work in the remote sensing sector.
For sure, space is directly involved in several of the development goals. For example, if we talk about climate, we have used satellites obviously to gather information about the situation of climate. Not only, but we also can use remote sensing data to mitigate the effect of climate change. For example, for the global warming, we can use satellite data for fire fighting, for fire hazard, and also, for example, to better understand what is the impact on oceans, and use ocean circulation data to see what is happening also to our coastal area. I mean, 70% of the population lives next to the oceans, so it will have a significant impact on Earth population. But not only, but we also help with solutions. Funny, how can satellite help to solve climate change? And I am very much in line with Dave when he says that is technology the key for solving some of the problems. For example, we can use GPS, and GPS is changing the way personal transportation is happening. We see a lot of this initiative, like, for example, car sharing. So you can, you know, instead of owning a car, you can share a car with Car2Go, Green Wheel. But all of them, they are now in a way that you need to bring back the car where you took it, okay? The A to B transportation is not possible yet. It's not very much enforced. When we will have a self-driving car that will go back to their point, and this will be thanks to very accurate GPS, it will change the way we move around in the cities. So improving the air quality, reducing the amount of cars we need, will have significant impact on the society. So it's not very direct impact in that case, but it's still making a difference.
Yeah, of course. And Luca, can you tell us something about satellite services in relation to zero hunger?
For sure, the large part of remote sensing data are used to understand the way we grow crops, to predict what will happen, for example, to food production, but not only, to enforce production of crops using less fertilizer or using less pesticides. So precision agriculture is the new frontier, and will be possible only if we develop very high performance hyperspectral instrument, like we do, for example, with the Copernicus, with CHIME. We will be able to see which cultivations are using non-chemical fertilizer.
Yeah.
And the SmallSat obviously will benefit from this technology, because with SmallSat we can have to very fast revisit and to have ready data for precision farming, for example.
Yeah, I think that also Alessandro wants to say something about this.
Well, we have some examples of this SmallSat development. We are trying to chase a bottom-up approach, in the sense that sometimes we have some other needs from some particular cases, or we have some availability of new technology developments. We try to match these things in order to get new ideas also going up, indeed, in order to find to foster new ideas also in the applications and also in the development itself. I like to mention, for instance, one of the examples, one of our hyperspectral R&D's projects. They were really targeting particular crops and potatoes fields in Belgium, for instance. So they were used to identify, let's say, to analyze in the hyperspectral region, the visible region, these crops by normal drones. They decided to try to investigate the possibility to do it via SmallSats. And SmallSats, why SmallSats with respect to big sats? Because indeed it's easier and faster, a very easy way to say, obviously, to develop this instrumentation and to make it flying quite fast, quite early, and with a reasonable cost. In that sense, we managed indeed to get some information, or we are trying to get, like, finished yet, to get some information that usually can come out from a very limited area, let's say through drones. We can put it in a bigger perspective, let's say, for themselves, for the Belgians to start with, but then they can use the same satellites with the same characteristics for other crops and other areas in the world, for instance. So there's quite a lot to do.
Yeah. Okay, maybe Davina and Francesco wants to add something.
Well,
yes.
Well, I think what we can also add to this discussion is that the capability that the satellite have to also bridge the digital divide. So and how basically, as I'm thinking about all the remote area in the world where there are billions of people which do not have access to proper education, proper information, health. So basically, they don't have access to all those rights that we, in this part of the world, we take as granted, and how a satellite can provide high-speed internet also to those remote area, for which providing internet from ground with fiber optic cable would be just financially impossible. So providing internet access from satellite would permit this part of the world to finally be connected. And we have seen during this year, I mean, with the pandemic, how important is the possibility to have access to internet, to provide education to our children. And in this side of the world, education continue to be provided because all our children had access to lesson virtually. So they were connected to their mates, to their teacher, they were getting assignments. So they kept progressing even in this sort of dark area of the pandemic. And so we could, satellite can help towards development goal like for providing quality education to everybody, but also health. I mean, we have seen surgery performed in those remote area, remotely assisted from more capable hospitals. So there's a lot that satellite can add to that. And we have seen recently in the last 10 years how big company, big name, new name, in fact, like SpaceX, Amazon, OneWeb, they are working in that direction. So providing internet access from everywhere in the world using constellation of small satellite. I'm sure we can discuss more later on that, but I think this education, health, and in a way also gender equality, when we look at women access to education globally, it's something that satellite can definitely provide.
Thanks. Please, Francesco.
Yes, I would like to add only two short points. One is that another goal in the list is peace. And with Earth observation, we can also monitor conflicts, for example. And so to know what is going on, particularly in small conflicts in poor countries where you never know who is doing what. And with Earth observation, it's easy to monitor and control and keep peace together with other actions. And the second point that I would like to highlight is that maybe not all the people that are listening to this roundtable, that now in space something is changing. We have a constellation of small satellite that will provide us the capability to observe the Earth with much more frequency, both in time and in space. And this will increase a lot the capability of our way to see what is happening on Earth.
Yes, I would like also to add, for example, one very important aspect about safety and security is the piracy. We see a resurgence of a piracy in ocean next to Africa and in the Far East, and also one of the events that is happening all the summer is the human trafficking. So with the faster visit and better intelligence, we can also help security to enforce law about safety in our oceans.
And also the so-called no cooperative vessels, for instance, they all belong to the security area. So it is still possible. We are doing some activities also about that to find out with small sats in particular, because they're not really the big institutional satellites, let's say to focus these some of these small sats, let's say some of these payload developments towards the observation of the so-called no cooperative vessels, which are those that are usually running during the night and with almost no lights. So with very low lights environment, let's say, it is not easy, but somehow you can adjust the development of some of these payloads towards some particular activity. So in the small sats world, you can either try to target, let's say, a factotum payload, like for the institutional ones, or you can target, which is quite more, let's say, well, it makes more sense, or say, target particular payloads for particular applications. One is, for instance, for security purposes, the no cooperative vessels.
Yes,
Yeah, if I can intervene, Elena, just one more second. One of the sustainable development goals is life under the ocean, and then you start to question how satellite can contribute with life under the water. And there is a very simple way to do that, and is, for example, we are overfishing our ocean, and one way to stop overfishing is by enforcing marine parks. And with satellite, you can see what type of vessels are crossing those marine parks, if they are commercial vessels or fishing vessels. So we can enforce law to protect our ocean from a satellite, and so changing even the impact of human activities with the life into the oceans. Another important aspect is the marine litter. It is becoming one of the most discussed, environmental problem we see. We have tons of plastic is going into the ocean and will be there for thousands of years, entering the food chain. With satellite, we can investigate the source of the marine litter and what type of plastic we produce and how we dispose it and how this is reaching the ocean. So satellite are also very important for life under the water, because it will give us more understanding of the impact we do, for example, with marine litter, and also understanding the way this garbage patch move around into the ocean and how to mitigate the problem.
And if I can add just a note that I in my mind while the other speakers talked, is related with the SDG 17, that actually is the partnerships. So satellites are very, even if they are small sats, they are still quite complex as a system. And they ask people to collaborate in terms of technology development and implementations as well. So it's, I would say that is a domain in which you need the others. And when I say the others means different disciplines, different nations, different competences, and so helps even building up the missions for a scope that you talked about so far, is a sort of a tool for building up very strong partnerships and collaborations over the borders as well.
Yeah.
If I may, just to back up what Michèle was saying, actually we are now shrinking down, somehow downstream and upstream, also development, giving some smartness to satellites, at the same time using data in a different way, extracting information in a different way. So even this is a sort of, joining competencies, shaking also hands between maybe different technology domains. So this is a very interesting fact. I would like to add maybe some salt and pepper to this discussion, asking you if we have enough time to tackle all the SDGs, because as you know, the SDGs are the 2030 targets. So we are now, 10 years to go. So I would like to know if we have enough time to tackle all the SDGs using maybe the satellite technologies or the satellite data, or we are still and already lagging behind, as it happened for the MDGs. If you remember the Millennium Development Goals were the ancestors of the SDGs, and they failed very badly. So I don't know if we are, what do you think, if I may maybe add another question, if you are in time or not, having just only 10 years ahead?
Yes, please, if someone wants to reply.
Otherwise, it's a question for the participants. They can write in the chat.
Yes,
what I would like to say, I mean, it's something that is philosophical in some sense, is that whatever we do, it will be in any case a step towards. So it will be a success in any case. I mean, I know that it's better to reach the goal as a whole, but to be above zero towards a goal is still a part of the success. So I'm confident that a lot of stuff will be done, even if the time is really short, as you mentioned. Also, thanks to the let's say speed the small sats allows to have, or are thought to have in the implementation from the concept up to the flight. So let's think positive, I would say.
Touch wood and cross fingers.
Acceleration of technology sometimes surprise people. And I hope it will surprise us in a positive way, in the sense that it's only with the acceleration of technology we can approach the objective of reaching the SDGs. How fast the technology is accelerating is very difficult to predict, because we have the law of Moore, for example, for computing power. But we can also have a similar law, for example, for cost of batteries. And we see the cost of battery in the last 10 years, it went down an order of magnitude. So how is satellite related with the cost of battery? You know, the cost of battery is related to the access to lithium. So with remote sensing data, we can discover new places where we can extract lithium to reduce the cost of battery. And using battery is a way to reduce the dependency on fossil fuels, because we can charge battery using alternative energies, for example, wind and solar panels. And the other interesting point about wind and solar panels, they are related to meteorological effect. So the prediction of how much power the solar panel on our roof or the windmill located somewhere will generate is very important to handle the grid. Because the big difference now is that while using a power plant using fossil fuels like coal or oil, they produce a constant amount of energy. Solar panels and windmill, they produce energy whenever they can produce it. So the handling of the grids is very different. So using very accurate weather forecast, we can also inject this information in handling the grids. And maybe powering the batteries that will be located in our backyard. They will be like accumulating energy used to use our personal mobility tools like electric bikes or small city cars, or even our laptop. So yes, the SDGs are very ambitious, but acceleration in technology, especially when sustained by massive investment, like we see now of the intervention of the European Union for mitigating the effect of the pandemic, 1/3 of about 1 trillion is going to be dedicated to the green economy. So 250 billion into the green economy. Yes, we can do a lot in 10 years with 250 billions, and especially if we establish synergy between various areas of technology, among which space will play a key role, in my opinion.
Okay, so I think that this point should have a round table
on its own, yes,
maybe 2 hours, and where we should discuss only about this, and maybe we will organize it. Why not? So thank you for your inputs, and I like it a lot to think about a connection between the deep sea and space, no, and satellites and their services are the connection. So let's go on in our roundtable and on our points. So from a satellite mission concept phase to the downstream service, even for small satellites as CubeSats, the way can take years and requires a certain amount of investments. So how space is evolving in order to reduce time and budget? Francesco, maybe you have something to say about.
Yes, I'm particularly involved with the upstream part, and I can say that now, generally, in the past, but also today, when you have a mission, you develop the satellite for that mission, okay? In the future, the idea is to develop satellite buses and payloads on their own, and then once you have a mission, you go to the shop, you buy the equipment that you need, and you can perform your mission in like few months or even weeks after you have conceived your idea. That's very different in respect to now, where you need years from the starting phase of a mission, the conception of a mission, and delivering the hardware into orbit.
Yeah, there's CubeSat shops already in online.
Exactly. The idea is that this should be grow. Also, because if you have a big market, the company that develops the hardware, they can fulfill the market needs without going for a specific mission, because there are a lot of things to do, and you can standardize the things. And also another point is software-oriented architecture. So when you have to change your mission, you simply are reprogramming things and not changing the hardware.
Yeah, thank you. Thank you, Francesco. And Michèle?
Yeah, I think that the key point is change a bit the let's say the approach to the risk management. And this is feasible with small satellites, because you can keep robust your mission thanks to the increase of the number of space platform to provide the service of the mission. I think I'm not an industrial person, so of course I'm not the best person to speak about that. But what I'm experiencing in developing satellites nowadays, we are building some CubeSats, is the long time asked for testing and for qualifying all the system before flight according to the standards. That they are beneficial because you at the end have a very robust elements to put in on orbit, but it takes a long way to, even if you have already all your technology in hands. So maybe that changing a bit the mind on the risk that we want to let's say to have and to face with our mission, and being a little bit more let's say courageous in sending stuff in space, reducing of testing for qualification. It's not the only brick, but could help in speeding up the whole process. Even if I'm not in favor of reducing the tests, because you are confident and you are, let's say, you can sleep in your night when you have done all your tests and you have all your passed the test for qualification. So this is for sure something very nice. But if the point is to be quick from concept to product, this could be a way or a point to look at a little bit to relax with respect to what happens now.
Thank you, Michèle. There's a question from the audience that is, how much does space debris affect the mission planning? Who wants to answer first?
Maybe I can try to give some feedback, because yes, of course, the rise of space debris, and if we think about constellation of thousands of satellites, which is what we are seeing not in the plan, but really in execution at the moment. I mean, Starlink has already started launching hundreds of these small satellites for constellation. The impact, the fact of having debris there, it is a concern. It is a concern because if the satellite doesn't have the capability to maneuver, if, for example, on a collision route towards a debris, it is a problem, and it is a problem that can have a catastrophic effect. So what I believe we should do is to plan to avoid to increase the number of debris. So plan to have a technology which allow once, for example, a satellite is has finished its operational life, or if the satellite stopped responding, to just call it down and bring it down, so burning through the atmosphere and not risking to be left there as a new debris. And also what we are already starting to envisage is mission that could look a way to remove all the debris, but this is a bit more on a long term. I believe that a first easiest step is to try to avoid to increase the production of debris that we have in low Earth orbit.
Yes, of course. Okay, thank you. Let's move on. Maybe Anil, do you want to say something?
No, you know, I just wanted to be provocative, like in the
You always
previous...
want to say something.
You hired me for this, huh? So no, because I'm the input that Michèle and also Francesco gave. They are, you know, somehow Michèle was talking about robustness and Francesco on resilience. So I'm not sure if both of these things can be done in maybe reducing cost or having at the same time a high quality and high, you know, robustness and resilience at the same time in a satellite. And the second provocative point was that democratizing the satellite access and satellite production is really nice and good, and also because we touched some points previously on education, on you know, widening like STEM and all these things. But remember also the syndrome of Kessler. I don't know if you have heard about that. So at a certain point, we might reach a time where we will not be able to stand maybe some probes in space because of the debris and because of you know, a lot of pollution also in space. So yes, I was just wanted to be a bit provocative on maybe robustness versus resilience, and the fact that yes, a lot of satellites is good, but not too many, maybe, or not too much.
Yeah, in fact, in the second part of this roundtable, we will discuss about propulsion systems and how the ability of nanosatellites and microsatellites to move in space will have an effect on the space debris and on the objects that when they are dead, they stay there.
I hope I've not spoiled out anything for the second section. Huh?
No,
if I can add just one single remark, small sats versus big sats, there's already a big tailoring in terms of tests and PA, product assurance, and so on. Indeed, we have the so-called ECSS standards, which are completely applicable to the big sats. But for the small sats or CubeSats, we tailor them, or we are tailoring them actually. It's a never-ending job, obviously. On the other side, many of these components, especially the electric components, are so-called COTS components, so commercial off the shelf, which means that there are some components that are already used in everyday life, so to say, obviously, and maybe tailored, not more than tailored, ruggedized a little bit, just reinforced with respect to the environment that we face on the space, with respect to the one on ground. But they're not ad hoc, completely new R&Ds in that sense.
Thank you, Alessandro. So let's move on. I would like to stress another point. So to make the world a better place, there's different point of views. One person at a time, one smile at a time. It's in this way that with the world can change is the motto of an Italian guy that maybe some of you know. building schools for refugees in the world. And I would like to hear your point of view on this. So maybe Michèle?
Yeah, I would say that the compromise is the best. So for sure, if you start from the bottom and you build up person by person, you will succeed, because the community is made up of single units. So every person's make the large community. So that makes sense, but you need to let's say focalize and funnel the energy, the creativity, the capabilities you have at the single level into a let's say into the same direction to have the best effectiveness in what you do. So I would add to the fact of building up a better world interfacing with the single persons. I will also add the fact that this must be, let's say, supported by a top-down point of view. So these two faces of the coin must stay all together. So in the space domain, I would say it is very nice to have a sort of volcanic energy from the bottom of the competences, SMEs, even single persons having new ideas for even the data exploitation. So put all the ideas in the basket, but then there must be at the top of the vertex, at the pyramids, the regulations and the will to translate it into something that is consolidate all over time to get to the final goal, I would say. So just an example, if we think of the navigation satellites like the GPS are, so the consciousness on how space is fundamental for the daily lives has been built through a service that arrived to every person on the surface of the earth. And so from bottom up, let's say, from the single human being, the consciousness of the fundamentals of the spaces support in the daily lives took place, but without a top-down regulation, let's say, or will. The Galileo evolution for the European navigation system would never took place. So both of them has to be combined, not only one perspective from my point of view.
Yeah, it's a fusion between bottom-up and top-down approaches.
Exactly.
Yeah, thanks, Anil. Do you want to say something about, I mean, do you agree on this, on one thing at a time when we talk about technologies, evolutions, and space data elaboration?
Okay, it's a hard answer, huh? Because you know, there's a lot of philosophy behind this this quotation, behind this sentence. Let's say in principle, no, I'm not that much agree. I don't that much agree on the one step at a time. Also because, you know, that African motto, because this one step at a time is an African motto, is coming from the same bunch of motto of African motto that is also under the umbrella of it takes a village to raise a child. So this means that you need to have a lot of different competencies. So you cannot focus on one maybe technology or one application only, because definitely we don't have time. And definitely you will need to see also if there are other applications or maybe other, don't take me wrong if I use the word contamination in these days, but you need to contaminate, to cross-fertilize, and to have maybe different technologies, different competencies all together. So maybe not one step at a time, but maybe one fertilization at a time. I'll give you just an example. If you go to a truck seller or an agriculture machine seller nowadays, you will see that they don't have only the competence on mechanics and maybe agronomics. They know a lot of computer science, they know a lot of electronics, and in the very recent models, they know a lot of, surprise, surprise, satellite data, Earth observation, and so on. It's incredible. So you need to have a lot of different competencies together. So I'm not that much in favor of one thing at a time, but maybe let's see one wider view at a time. Maybe, yes, I will go more on that, because it takes a village to raise a child again.
Thank you for saying this. There's someone from the public that wants to share some thoughts about this point. Please write on the chat. And is there someone else from our speakers that wants to say something about?
I may add something, if you allow me.
Thanks, Luca.
For me, it is important when we talk about education, how far is space technology from the general public? Now, access to space technology is only possible for developed nations in which we have universities, in which we have aerospace education. Then what we've seen with the CubeSat, for example, the number of universities having a stream on space increased enormously. So we can say the CubeSat has made access to space technology, the barrier of access to space technology, a lot lower. For me, the next step, it will be to make space asset available to the common public. So maybe with artificial intelligence, with autonomous spacecraft, especially with small spacecraft, somebody can rent a satellite and task the satellite to specific investigation. So any student sitting somewhere with an internet connection can have direct access to space asset. So this will lower the barrier of education of kids on space. Obviously, as anything, will have sort of secondary effect, because even people with bad intention can access a satellite and to use them for purposes that are not so nice, like it happens, for example, with internet and social media. Okay, social media has been a very good way to give people access to education, but can be also used for wrong purposes. So for me, the next barrier is access to the space asset remotely.
Yeah, in a secure way, I would say.
In a secure way, in a controlled way, yes.
Yeah, thank you, thank you. So let's move on. There's a point that I like a lot, that it's related to the fundamental human needs. So there's a classification from Max-Neef that lists them as subsistence, protection, affection, understanding, participation, idleness, creation, identity, and freedom. So how do you think that the satellite help in satisfying these needs? Is human being curiosity that take us towards the space exploration that is so much discussed and as much needed in the world? Michèle, how space exploration declines these needs?
I would say that exploration is the curiosity of the mankind from the scientific point of view, but is also the challenge of each of us with respect to our capabilities. So it's an intrinsic need of the human beings. So that one is, I mean, the exploration of the solar systems and further, or even not necessarily related to the solar systems, but all the science done in astrophysics to understand the evolution of the universe, the past and the futures of the universe, is clearly linked with the intrinsic needs of a humans. But and with respect to the needs that you mentioned and the classifications of needs, you find the mapping quite immediately, because you see the freedom, the creativity, the identity, even in the sense of humans, well declined and answered in developing satellites for explorations. But all the others needs that are listed by these economists actually are can be mapped in what has been said by Luca, by Alessandro in your first questions, let's say, with the services that satellites can offer. So it's you may have a map one-to-one and more with respect to each of the 9 needs with an applications in space. And I think that we can spend hours in, let's say, passing all the missions and all the services, all the goals that satellites answers that can be translated into one or more than one of those needs. I avoid going through all of them, but if you look just at the Earth observation, the defense, the planetary defense in terms of protection, in terms of Earth and stuff and threats coming out, let's say, from out of the Earth environment. So, so asteroids or stuff like that. So all of them are completely, I mean, it may be because I'm working in that environment, it seems that each of them finds declinations in space quite immediately.
Thanks. And Luca, can you tell us something about also, thanks to your experience in the scientific missions as Rosetta and Cassini?
Yeah, this is what is for me one of the most fascinating professional experience I had. Okay, so if I think that I contributed to exploring the moon of Saturn with Cassini, just I get goosebumps even today after 30 years. And this is very important when we talk about participation. Okay, everybody can participate to human exploration. Exploration done by humans, even with robotic spacecraft, by studying the result of the investigation done by Cassini and dreaming of landing on a comet was something that it's, I mean, how can I say, for the human being, something, an achievement that will remain for a long time. So, and then again, we can think about participation if we can build, for example, a small sat for astronomy and make the small sat for astronomy available to students. Why not? And me and Alessandro are author of a paper will be published in Nature the next month, in which we are analyzing the opportunity for using philanthropic money for education through space. If you look how much money is used by philanthropists, especially in the United States, where philanthropists are more active than in Europe for tax reasons, they spend something like $500 billion in philanthropy, of which 1/3 is for education. So participation to space technology can also be like making a space observatory, a small one. For example, 300 millimeter, a small spacecraft, and everybody can access and use for education and even to find new discovery.
Thanks. I felt your vibration while you were talking. Thank you for your contribution. Maybe Alessandro or Anil, do you want to add something to this?
He said everything.
It's very, yeah, it's a very high level thought. So I don't want to interfere, but well, you know, in the past years, so maybe only few of us can that curiosity killed the cat. rock band, if you remember. But I must say that curiosity killed the cat, but saved the mouse. So there is always, pros in curiosity, and definitely curiosity is part of the human being and is part of the human sense. So we showed that curiosity also in technology and exploration and space exploration, it's always something that might maybe save the mouse. So in this case, save maybe also ourselves as well.
Yeah, you're right. Thank you. Thank you.
Curiosity belongs to human nature, so that's also can unify by far the different distinctions and divisions that we have in there.
Thanks.
But then we go to too much philosophy.
Yeah.
Okay, let's move on. Let's move on.
Too much high and behind the stars,
Okay.
below the stars. So
I just want to add a point that the curiosity push the space exploration for sure, but also I would say the Earth observations as well, because it's the need to understand the more and to dig the more, even words that you think to know, but you have a lot of to understand the more. So it's not only looking, let's say, outwards, but also downwards. So it's the same push, even if the mission is not going very far away.
But if I may add something, Elena, 1 more minute, if I can have it. One of the, let me say, most interesting topics nowadays is finding life outside Earth, okay? So very recently we heard news about amino acid on the atmosphere of Venus. And there's a number of missions that have already discovered hundreds, if not thousands, sorry, of planets with Kepler and so on. So this is also a very fascinating topic in which a combination of big missions and small satellites, Coro was a small satellite, one of the very first ones discovering exoplanets, is so fascinating that will also attract a lot of young kids into space and technology and study physics and mathematics. So that's another opportunity for space to get closer to a broader community.
Yeah, yeah, of course. Okay, now we can enter more into the details of the services that are offered by satellites, including space exploration, of course, and how these services can be more effective with the innovations in the propulsion system domains. That's what I do, both for access to space and in space applications. So let's move on in the access to space relation. And here I'm talking about the possibility to launch nanosatellites with waiting times of 1 week and paying with the credit cards. So how this new paradigm will impact the satellite services efficiency? Francesco.
Yes, for me, access to space, it's fundamental to make every space activities, so all the activities in space, like a self-sustaining business, because now it's a lot reliant on governments, everything we do in space, but we need to shift to a full self-sustainable business market in space. And for doing this, we need to go where we want, when we want, at an affordable price. Now there is a lot of activity about access to space, different solutions, hundreds of companies working in small launcher, so putting small satellite directly where we want, or for example, developing dispenser or propulsion, so you can go in orbit with a conventional launcher and move to the right orbit. And also considering previously we were talking about the Kessler syndrome. If we can go everything where we want, we can split the satellite or more layer so that they don't interfere each other. Because, for example, now the majority of small satellite, they go in polar orbit because it's the typical orbit of big launcher when they go to LEO. And so having a different paradigm of access to space will change a lot the way that we will do things in space.
Yeah, thank you. And this may also, I mean, for small companies that want to perform in orbit demonstration missions, I mean, the waiting times today are still high and costs also. Davina, what about being launched in batches for microsatellites constellations?
Well, as Francesco was mentioning, in fact, all these CubeSat, when they start with a different aim, which was education for university mainly. That's how the concept of CubeSat was started. So there were a few of them sent by certain university with a aim to just perform really education, teaching the student, the aerospace student, how to build operating a satellite. But what we've seen in the recent years is really the shift towards the utilization of this CubeSat for governmental purpose, for more civil Earth observation, telecommunication, information. They're all planning to start using them. Now, we see plan for constellation of this CubeSat or small sat being envisaged. Now, the main problem with that would be that, of course, in order, for example, if you go back, we go back to what we say at the beginning, to provide entire coverage. So we need a satellite to cover all Earth. We need a satellite to be able to move to the location where they need to be. Now, envisage a satellite launcher of 1,000 of these satellites to the right location. Of course, it could be an option, but it is probably not the most efficient one. What we are now trying to prepare is to prepare the technology, the propulsion technology, which would allow the satellite that are launched in batch, because this constellation, we're talking about 1,000 of satellites, so they will be launched in batch. So in order to be able to move exactly where they need to be, they need to have onboard propulsion. And this has been recognized by our agency as one of the main needs. So we need to prepare the reliable propulsion system, affordable propulsion system, and miniaturized propulsion system that they can fit inside the CubeSat and that are able to do the constellation deployment. So do maneuver like moving to the orbit altitude or to the inclination of the orbit where they need to be. And it's something that we are already starting investing. It's something that we have seen really change. We have a lot of European company already busy, and in fact already having done flight demonstration on this. Of course, we are still working on it, but things are accelerating very fast. I mean, we in the past developing propulsion system for space, what was a big endeavor. I mean, there was a lot of time and money behind the readiness of a propulsion system. Now we see propulsion system for this purpose to be developed, being developed in much shorter time and with a fraction of the cost. Yes, we can. I already expect Anil question is the debate is how much risk we are ready to take, because when we can build propulsion system made out of commercial off-the-shelf component, but of course and not extensively test to the end of life, but this will bring some risk, and that is the main question we are at the moment trying to answer.
Thanks. Anil, if you want to say something as you are an expert on business models.
Well, let me just back also what Davina was saying, and maybe also what came out from the previous questions. So technology is running fast, and innovation also is running as fast as technology. So this means putting more technologies, different technologies together to create new innovations and new applications. But what we see also from the agency point of view, because we are also supporting the startup ecosystem, the startup creations, and so on. we see that these new technologies and new set applications are also putting in place very interesting new business models. Also in the satellite market, like I just, I can name few, like we found some servitization approach in the satellites, like satellite is just a commodity and we are selling you maybe a service based on that satellite. But we also see some interesting business models like the Nespresso model. So I just gift you the satellite or the constellation, and then I will price you maybe other on top of that services or add-on features. So it's interesting. It's interesting because the satellite market is growing very fast, and we are having also new and different applications and new business models. So from the business and market perspective, we are really living in really interesting times. So yes, I've seen very cool things in the past, and I'm pretty sure that cool things will come also in the next months and years.
Yeah, thanks, Anil. There's a question from the audience that is, how do you think that this will change also the access to space for less developed nations?
If I can answer, go.
Okay. No, go, Francesco. I didn't know if it was a question for me or for
For
the panel.
all of you.
So I leave it to Francesco.
Okay, it will change a lot because we know that now we have like 7 nations, something like that, going to orbit directly with their own launcher. Surely there are a lot of micro launchers that are being developed in countries like Australia, Taiwan, and South Africa, Brazil. So probably a lot of countries in the world will have their own access to space capability directly, or even in some way with partnership with larger countries, building their own small satellite and putting them on a commercial launcher, for example, like a Falcon 9 or something like that. So we'll change a lot the capability of, let's say, less developed nation to access to space.
Thanks. Also, the other speakers agrees with Francesco.
Yeah, we also see initiative like rideshare, in which people start to use launcher like charter. Okay, so a company buys a launcher and then eventually later on sells slot on that launcher, like a company is buying a chartering an aircraft and then selling seats afterwards. So rideshare is also an opportunity to jump on board of a rocket at the very last minute, because one of the problems we have now is that you need to develop a satellite and then finding a launcher. At least sometimes it takes more time than developing the satellite itself. So rideshare for me, it will decrease the time to get on board of a launcher, and give opportunity to people that are have more difficulty to predict when they will finish the satellite because they are newcomers, to jump on a slot on a launcher.
Thanks.
I would like to put on the table also the point on air launchers. That is a way, I mean, launchers with the first stage or energy gap given by airplanes. So this is another way in which you can speed up the enter of other nations into the market or in the arena, because it will be definitely faster and cheaper if you have the opportunity to exploit this kind of strategy to put stuff in on orbit, and not the classical rockets from ground with a large payload to be clustered before getting to launch.
Yes, this is also interesting for countries that do not have the sea, it's and the first stage is always reusable. So this is obviously interesting.
And it is quite fast also to be put on orbit. So it's quite timely. Whenever you want, you can launch in principle.
Yeah. Okay, so let's
maybe
please, Davina.
Just would add that, yes, I mean, of course, there are all these initiatives on micro launcher, and the one that Michèle mentioned on using sort of airplane as a first stage. But the main point that we see as technology where we should try to focus the attention is then how do we ensure that the satellites, which are launched in batch, so you will be launched, you will be placed wherever the third stage or the launcher with the right share take you, how does it then reach the exact location where they need to be? And when you launch in batch, this is fundamental to have then the possibility to have efficient and a reliable propulsion system that put you then on board propulsion system that put you take you where you want and you need to be.
Oh, thanks, Davina. You touched the point of my question, the question that I was going to ask you. So please, you were talking about this. So can you tell us something about Argo and how propulsion capabilities are crucial for these and for what kind of missions?
Well, having onboard propulsion, as I said before, it's if you started to think about utilization and of these CubeSat, small sat for vast application, constellation for Earth observation, Internet of Things, information, telecom, the capability, the availability on board propulsion become crucial, because on board propulsion means that you can suddenly compensate for drag. So you can extend your mission duration because when a satellite is placed in low Earth orbit, is attracted by the gravity. So it will fall down if there is no means to compensate for the altitude. Propulsion system allow you to control the position, to make the satellite work in formation, but also, as we mentioned before, for the case of avoiding generation more debris, it will allow you to do collision avoidance maneuver. So suddenly these satellites that are in a large quantity, that of course they are placed in a large space, because space is quite big, even in low Earth orbit, but these satellites are traveling to an enormous high speed. We're talking about 25,000 kilometers per hour. So any small object in the route of collision to the satellite will have a catastrophic effect. So you will have to have a propulsion system which allow you to do that, and you need to have a propulsion system which allow you to bring down the satellite when the satellite is no longer used. And this is for when we talk about Earth observation, for telecommunication, technology demonstration mission. If we move far away, we can even think about utilization of this small CubeSat, small satellite, even for exploration. We have at the moment a mission in the agency, which has been just recently signed, which is called Margo. And this is a mission that will take a small CubeSat, which is something just bigger than 12 kilograms, so a very tiny satellite, on a course to an asteroid to really analyze and study what are the capability of this asteroid to be able to be mined, to be able to be used, the material of the asteroid, for future exploration. And you can do that with a large satellite, but that costs quite an extensive amount of money. So if you can do that with a small, cheap, in a way, CubeSat, then of course you have done a lot of your preparatory exploration, so where you go to a place to observe before you send the large satellite. And to do so, we are investing on developing propulsion system that can take to a long way down to an asteroid, but could be also down to the moon, to the Mars, and which is a new way of seeing propulsion utilization.
Yeah, is ESA doing also other financing other programs on these propulsion systems development for microsatellites?
Yes, in fact, as I said before, ESA has recognized these needs that that as soon as this CubeSat, the microsat, becomes needed for different kind of utilization that what was originally conceived for, then we need to have onboard propulsion. So we have started activity on developing propulsion system for CubeSat and for microsat, and these propulsion system are really small. I mean, they stay in a size of a CubeSat. And one of those that I'm happy to mention here is developed by T4I. It is a novel type of electric propulsion system which can enable the mobility of this CubeSat. And so at the moment we are looking at means to bring a subsystem which was already pre-developed, so it's already in a form ready to flight, but we want to see the next step. So the next step will be to assess and to refine that subsystem in order to make it available to more utilization space. And we have a different contract running, and some of them are tackling really certain particular issue, which is, for example, the debris mitigation, the disposal, because having a propulsion system to dispose the satellite, it is, I believe, is one of the key. We have another contract that we are developing really a sticker. So it's a propulsion system in a sticker, which could, independently from the capability of the satellite to receive a signal or to send the signal. So imagine the satellite is completely offline. We can send still a signal to this propulsion sticker, commanded to bring the satellite down. So we are still at a really low TRL, low level of readiness, but it is just one example of how the agency is investing in developing this future propulsion system for this particular application.
Thanks. There's a question from the audience about this. That is, which system should be better to place small sats on the right orbit? Kick stages placing them in the right place, or on board small satellite propulsion? I think that we answered to this question, but maybe you want to say something more?
I think it's a bit of a combination of both. I mean, it is always mission dependent. You need to have a kick stage to bring you for certain to certain location. But then, if we are talking about launching one, two satellite, or even, I don't know, a few handful of satellite, it might be convenient. But if we start talking about batch of satellite for constellation, then we really need to have a means to ensure mobility of the satellite in space.
Yeah, what do you think also, Francesco, on this?
Yes, it depends, because there are some trade-off. For example, generally when you have a small propulsion system tend to become less efficient as you go down with scale. So from one side, the propulsion system of the small satellite will be less performing than the propulsion system of the first stage or a dispenser, for example. So probably the best combination is to do a significant part of the initial delta V, so the velocity increment with the first stage and or the dispenser, and then the last adjustment of the orbit, the phasing with the propulsion system on board of the satellite. Also because a propulsion system on board of the satellite can be used also after deployment for other reasons, so station keeping and so on. So it's always good to have its own propulsion system. But for small satellite, generally having an help from a dispenser of a launcher can be helpful to decrease the requirements on the small propulsion system.
Mm-hmm.
Thanks, Francesco. So I would like to take the chance to move on orbital transportation. So to think about to have orbiting fueling stations and satellites moving as cars. So how much this vision in reality is reality today? And do we have to expect motorized satellites or shuttles that move satellites to their operative orbits? So how far we are from this DHL view, transportation view in space? And this question is for all of you. Anil?
Oh, I'm always the... well, I guess it's not that far, this vision. But of course, this is a collective effort. So it's something that not only one agency or one actor can do, because you need to have a bit wide. You have to make it on a wider stage. What is intriguing me is maybe this is a bias of my work, but what is intriguing me is the possible applications of all of these technologies on Earth. So what we can do, like having the space DHL, as you mentioned, but trying to see if the technologies or whatever can be also of impact, of great impact on Earth. From an agency perspective, we are definitely supporting new projects and new initiatives, but again, such scale of initiatives is not something that we can do alone, and we need to have different collaboration agreements, and this should be also one of the main programs. But it's not something that is not doable. We have the technology. We might be in need of some step forward, but in my personal opinion, it's not something that is so far.
Okay, give us a number. Give us an year.
Oh, I'm not the person of numbers. I'm a provocative man, so I'm not number man. I'm not figure. But okay, let's say that we might have the same target of the SDGs.
Oh, great!
Why
I like
not?
your answer.
We have technologies, so we just need to put it in place.
Yeah, you're right.
But I think maybe I'll add only one thing, that we do see already, we have already the technology, for example, that would prepare for such kind of mission. For example, if I look back to the design of OneWeb satellite, they already sending up to space a satellite which have a handle that are there in case in the future there will be the technology ready to grab the satellite and move them around. That could be up to different orbits or to bring it down. So we are already preparing for that technology to be ready. And it's a small, step, but it's already make you already think that we are working on that direction.
Yeah, there's a question from the audience that is not completely related to this, but it's related to the fact that there will be, if there will be satellites or cars or transportations or refueling stations and so on, that is about the astronomy community concern about light and darkening pollution due to the increasing growth of satellite constellations and so on, as I said. So how this can be dealt with it in satellite design and regulation? Are space agencies and universities and companies doing something on this?
Okay, if I can answer. One of the claim by the astronomer, they try to find solution, also to propose solution to this problem, because, for example, with the Starlink constellation, they have a lot of problem seeing some traces on the images, and they propose to lower the orbit below a certain threshold, because this will improve their observation because of the light and the position of the satellite respect to light and the shadow of the Earth. And this is good also for other aspects that we were talking before. So, for example, the Kessler syndrome, the problem of the debris. One, in my opinion, of the paradigm of the future will be to add a propulsion system on a satellite and to decrease the altitude to a level like, for example, 300 kilometers, where the satellite is not able to stay without a propulsion system. Because if you put dozens of thousands of satellites, even 100,000 of satellites, if you see what are the propositions for the future, if you have an active deorbiting system, it's difficult to have 100% reliability, particularly if you have a trade-off between cost and reliability. And so there is always some probability that something bad would happen. And with such amount of satellite, it will be a mess. So if you stay at low Earth orbit in drag compensation, when the satellite stop to function, it will come back passively. So drag compensation, thanks to propulsion system, is very good for the astronomers and very good also for the debris mitigation, and also had some other advantages, like you have some shielding of radiation from space, so you need less rugged electronics, and also you improve the resolution of your optic. So I think that is a path that we need to explore, because in some way I don't see much alternative to that.
Maybe
but we need a wide consensus. We need a wide consensus on that, because just making a joke on what Francesco said, just changing one letter, one vowel, you can pass from a critical mass to a critical mass. So, you know, we need a wider consensus on this sort of decisions, because it's something that will not affect only maybe one part or another. And the other aspect is also, unfortunately, on the commercial viability, the economic viability of such initiative. We are now, because of the new space economy, let's say, we are now driven a lot by commercial sustainability, which is good in to some extent, like the reusability of launchers and so on. But from the another point of view, it's not that good, because when commercial aspect is coming into the picture, so if this is a commercial viable or commercial advantages, I can make it, otherwise I will not go for that. So we need a sort of trade-off between the commercial part and also a wide consensus on this.
But I agree that light pollution of satellite is becoming a problem for astronomers. And so far, there is no regulation about how much light pollution a satellite can generate. So maybe in the future, we need to also to think about designing satellite in such a way they will reduce the amount of light pollution they generate. For example, using different type of design of solar panels and different type of operations, they can reduce the light pollution they generate. But it's becoming an issue. This is recognized.
Yeah, maybe this should be considered in the design phase of the satellites. I mean.
Yeah, but should be considered, you know, by whom? Because obviously it will be an additional burden for the one designing a satellite. So leaving it to the self-responsibility of people, it's okay, but maybe it's not enough. So it may become an additional requirement, like, for example, space debris, also light pollution, okay?
But it takes time.
It will take time before the community
and consent.
We recognize the problem, and the community, in the form of the European Space Agency or other agency, to impose standards on light pollution.
Yeah. Okay, thanks. We have 5 minutes more, and I would like to propose you a question from the audience. That is this one. SpaceX demonstrated the economic advantage to achieving reusability like planes nowadays do. Is reusability for launchers a direction that agencies are following?
Okay, let me just try to make a short answer on this, being an
thanks.
agency. Okay, we are not achieving the sole reusability target, but basically in the new tenders also and the new projects program supporting, we are trying to see the best value for money and the best technology applications we can find. Definitely, as we started this session talking about SDG, definitely if we can have some sort of impact also on greening space sector, or somehow reducing also the cost and the CO2 impact in such a way, definitely reusability is one of the assets, but it's not the unique one, it's not the specific one. And again, linked to the previous answer we gave, we need a consensus. So it's something that, we need to have also other on board for that. So yeah, it's not a specific element, but it can be part of a general projects and general things we are supporting as of now.
Thanks, Anil. Someone wants to say something else about this point? Francesco?
Yes, in Europe, we have also at ESA level, we have a Callisto program. We have some program after Ariane 6 that are focused in some way about the reusability of launchers. So in the near frame, in the near time, there'll be Ariane 6 that is expendable and to fulfill the requirements of the European needs. But then after that, probably there will be another generation that will be reusable probably.
Thank you, Francesco, for your inputs. Okay.
Well, I don't want to be seen as the one who is very much, linked to money and economics and figures. Okay, but SpaceX is also a peculiar case. In the last year, SpaceX raised up $800 million dollars. So it's not that easy in competing with such budget.
No, not at all. Okay, so I think that we came to the end, and I felt honored to have all of you here today, both the speakers and the participants online. And it has been a great discussion, and I hope that you all learned something today, that this is important for me. And don't forget to have a look to our event on the T4I webpage. As in a few days, you will find there a brief report of this event, and we will reply to your other questions that we received in the live chat. And you will find also the link of the video in our YouTube channel as we recorded this roundtable. So what can I say? Thank you, everyone. Thank you, speakers. Thank you, participants, for being here today.
Thank you, Elena.
Thank you, Elena.
Thank you.
Bye-bye.
Thank you.
Thanks to you.
Bye to all. Ciao.
Bye. Ciao.
Ciao.